Hello, welcome. So in this series, we're building a C compiler for my CPU, and we're doing it with data-oriented design, and we're trying to do it incrementally for the most part. Not entirely succeeding, but that's okay. We do have the entire pipeline from beginning to end mostly working, although there's a few key pieces that are missing. So you may notice that some of these files have been modified. This is kind of an experiment to see what you guys think about this, but I tried to record it and it didn't go very well. So one of the most important things about a compiler, in my personal opinion, is the error handling. And I'd like the error handling to be good, but that's kind of boring. It's just one of those things that you got to do because you got to do it. And I don't know. I don't think it makes a good video. I mean, I'm sure pretty much all of you can handle producing error messages and reporting errors and stuff like that. So I don't think there's anything new about it. I'll go through the code anyway, and if people are really angry about it, maybe I can upload the video. It needs quite a lot of editing because it's, yeah. So yeah, if you really want to see the video, post a comment down below. Maybe I can just unlist it and not do as much editing or something. I don't know. Maybe also mention what you would prefer in that regard. Okay, so let's go through the code. There's not a lot. So I ended the previous episode on a cliffhanger. Let's actually do that first. So there was a comment that I should just switch to Rust. I think that's a little extreme. Rust is, let's just say that I could be learning it for years and not really be super good at it. It's kind of similar to C++ in that regard. I kind of feel like it's a language where you could be doing it for a decade and you'd finally actually be really good at it. C, I feel like, is in some ways like that too, but I have done it for a decade or more, I think it was. I don't know, it was a long time ago. Anyway, I'm rambling again. So you can turn on the address sanitizer. This doesn't work on all platforms. Windows, I think the address sanitizer works quite a bit different than it does on Linux and Mac OS. Although I'm really not sure about that. At any rate, this is what works on Mac, and on Linux you can use a program called Valgrind, I think. And I think Valgrind does the same thing, although I've not really used it. So these tools didn't exist when I was doing C. I had to figure out where the memory errors were by hand back then. And that was fun, I tell you. It was very fun. Sometimes it would take a week to try and find it. But this basically tells you where it is right away. Here, I'll show you. So here we go. And it's compiling, and bang. It blows up right away, and it tells you exactly where the problem is. And it's in ast.c, line 29. So if we go to line 29, it's right here. And you might be like, well, it's been all allocated. Everything looks fine. Why would this cause a memory read error? That's basically a heap buffer overflow. And if you look at this code for a little while, maybe even pause the video and see if you can figure out what the problem is. All right, you're back? You sure? Okay. Well, so this gets initialized up here, and it gets initialized to 0. So what's 0 times 2? Yeah, AI wrote this, but that's not really an excuse. I looked at it and I thought it was fine. Yeah. No, 0 is what this would be, and then this allocates a buffer that is 0 sized. And for some reason, that's not an error. Like, it doesn't return null or anything, so it didn't crash. It just merrily kept on working, even though I was overwriting some of the heap, which of course was causing all kinds of trouble. So yeah. But thankfully the address sanitizer, finds it immediately and tells you exactly where the problem is. So what we need to do is just add in something like this, right? But I think a better fix would probably be not to do this myself and to use the SDB DS library, because all of the code in there has already been tested and known to be bug free or relatively bug free. So let's do that instead. And then I think here I need to go free and in gauzy.h, I don't need, where's the AST? Here we go. I don't need these anymore because they'll be included. So yeah, this is kind of why I didn't want to do this refactor, but because there's a lot of places where it is. If, yeah, no, all we need to do is, and then all of this disappears. And then we don't need to do that anymore. I think we can just replace all of this code with our ints. We're doing array free here. Okay, I think that's all the changes we need. Let's test it. Everything passes. Excellent. Just want to make sure that it actually works too. Okay, that seems to work too. That seems to work. Okay. So let's go through the rest of the changes that I made between episodes. So I guess in gauzy.h, there is a new region here named error. I've got errors. It's just a message and a token. The token contains the position of the error. And then there's an error list, which contains the source. So then it knows what the line numbers and stuff like that are, although that's not implemented yet. And then there's just an init, a free, whether or not it has errors that just returns a bool, and a way to add an error that is a printf kind of thing, and then a way to print all of the errors in the error list if it has errors. So the implementation is really straightforward. I'm really loving this syntax. That's a new favorite thing. We have to go through and free all of the error messages, and then we can free the whole array of errors. If it has errors, then the array length will be greater than 0. And then just this weird VA list stuff to handle allocating the strings here with the printf formatting, and then putting those into the error list. And then there's printing all of the errors, and I have a couple of to-dos here. We only have a single line, so there's not really any code to figure out what the line numbers are. It's pretty straightforward. You just scan the source text for new lines, and that only happens if an error happens, so it's okay if it's slow. No need to cache that or anything, although we could if we wanted to at some point. And at some point, once we handle pre-processing, we'll have to redo all of this because line numbers are going to be difficult to figure out at that point. And then we've got an upgrade with file names because we don't have any file names, but that'll just be in the source. Okay, so we've got errors here, and then I just went through and added in errors. Not sure what I did here. Oh yeah, we were just in here doing this. So there's nothing in here that changed. It was in token.c. There's a handling of error tokens right here. I think I might actually remove this because this error gets reported several times. And to avoid that, I'd have to redo how token peak works. And I did try that, but I couldn't get it working for some reason. I might try that off camera between episodes to see if I can refactor this. That was a comment on one of my videos. Why rescan every time we peak? Why not just save in the tokenizer the peaked token? Which is a good point. Could totally do that. So I'd like to change this to do that, but again, for some reason I couldn't figure out how to get it to work properly. So I will do that later. So yeah, there's also a new token type, the error token. And if there's an unrecognized character, it returns error rather than invalid, because invalid just means that it hasn't been initialized yet. It's a blank token. That, yeah. Error, on the other hand, means that it hit character that it didn't recognize. And it'll skip over the errors in this code here when it's finding the end of the token. It'll just skip until it's not an error anymore, which is what I actually want. Now, if it was invalid, then if an illegal character started the file, but that was considered an invalid character, then this wouldn't detect the error. It would just skip over the initial erroneous characters and then continue parsing on its merry way, which I don't want it to do. And it was too complicated to try and distinguish the two different meanings of invalid, because at the beginning of the file, the token will be invalid, and that's not an error. So yeah, so now there's just two different tokens. Invalid, meaning it just started. I could rename this to beginning of file or something like that if I wanted to. And then error is an actual error, and it might be better to put this right here or something like that rather than at the end. Doesn't really matter. Yeah. What else? So then in the parser, I changed the parser to have an error list. The tokenizer also has the error list. So I think in the initializer, wherever it is, yeah, right in here, it's just grabbing the error list from the tokenizer and initializing that field with it. And then we've got, so yeah, we've got the error list, and then in here, we just add errors to it as we go. It just gives the token so it knows where it is, and then whatever else you want to give for messages. And expect token is generally where the error is produced. But you can also have in parse primary if it's something that it doesn't recognize yet. And then in parse binary, I don't think there is anything. Yeah, so I think that covers the changes. Hopefully a summary like that is okay. Again, let me know in the comments if you disagree and you want to actually see me build that code. So what should we do in this episode? Well, I really want to get into register allocation, but right now we really don't need much for a register allocator. We've got the code generator that we built in the last episode here. And it can cheat. It can just hard code A0 as the register that it uses throughout. So it would be nice to have enough features implemented such that we actually need proper register allocation. So there's a few different ways that we could do that. Probably the simplest is just to add more operators, because with operator precedence, we'll need more registers to keep track of the parts of the expression. So that's probably the simplest. The other option is to implement variables, essentially. Variables is a much bigger task, and the way ChibiCC implemented it was in two parts. He did just single letter variables at first, and that allowed him to do like kind of half the code in one commit. And then in the next commit, he actually implemented a proper symbol table and all of that. That's quite a bit more work than I'd kind of like to do in one video as well. I think if we implement more operators, then that'll get us a good chunk of the way there. So what ChibiCC did next was to implement basically multiply and divide. And did he do modulo? No, I think it was just multiply and divide. But the problem with multiply and divide is that my CPU can't handle them natively. It actually has to do a function call in order to do multiply and divide. So that is way too complicated. So I think I'm not going to implement multiply and divide until we have function calls implemented. So then that leaves us with like basically bitwise operators and all of the comparison operators and left shift and right shift and basically that, but just these. So that leaves us with all of these that we can choose from. These, I guess they do produce an integer, so it's not too complicated, but I think maybe we can, maybe even just all these three, we could do bitwise operations. That seems reasonable to me. So I think I need to look up some operator precedence stuff, so I'll be right back. So here's the C operator precedence table. We've got plus and minus here. Oh no, that's your unary or unary. Unary? It doesn't really matter. So then addition and subtraction are here, and they're at precedence level 4. Bitwise operators are on separate, like they're all here and they're all at separate precedence levels. So we could do that. And then we can get into Pratt parsing actually. So let's do that. That would be in the parser. First, we need to be able to tokenize them. So we need to add tokens for it. That would be in Gauzy H, I think. Yeah, tokens. So then we need TK and or XOR. And is overloaded to be the address of operator. So I think I need to call it amperand or just amp for short, I guess. Yeah, and for multiply, we'll have to do the same thing. It'll be star, probably, because it has two different meanings and I can't give it the proper meaning here. Style-wise, that is kind of ugly because it's not consistent. It would be better to call this and. Yeah, if it rubs you the wrong way and you're implementing this, you can make different decisions. I'm just going to leave this for now. Yeah, maybe fix it later. We'll see. Oh, it just occurred to me that maybe we should check in our changes so then it's easier to see what we've done. Let me just do that really quick. Okay, let's redo that. Okay, so now we have to recognize these. We have to add them to, we need to add them in here. Move this up here. And then we add them here. Thank you, Copilot. And I think that's all we need to do here. Yeah. Then we've got the parser here. What we need to do in order to support Pratt parsing is we need a precedence table. And that's not quite what it says in here. Let's actually just use the same numbers from here because that'll just make it easier. So add and subtract are 4, and these are 8, 9, 10. And then for Pratt parsing, I think I might have to look up a reference just to make sure that I do this right. I think it's this one. Yeah, this one's in Rust, which is a little difficult to read, but not too bad. So there's a loop here. Okay. Let's just skip down to the end of the article where it gives the proper code. So let's see. You got Elixir, they've got postfix and infix, which we might actually need. So they're looping if, let's see if there's a simpler version of the code here before they get into infix and prefix. Infix, yeah, here we go. All right. So they recurse here unless this is less than the minimum, and the minimum comes from, okay, let's try this and see if this actually works. So we've got our precedence, and then we need to int. It's basically what we do. I think it's supposed to be less than. Yeah, it's less than. Okay. And then this needs to be parse binary again, I think. There, I think that's what we need. And then here, let's see. 0. 0 is the precedence you start with. Okay. Let's try it out. Tests. Let's see. Okay. Copilot's not helping me with these tests. All right. Let's try okay. So we've got all of the new operators here. Let's see what it actually produces, because I'm not sure this will even work. And it failed. Of course it did. That's actually, did I undo fixes here? Yeah, so it's doing right recursion, which is not what I want. Like I wonder if this needs to be greater or equal. No. Wait. That seems correct. Excellent. Okay. I guess Copilot was right. It's less than or equal to. All right. Let's see here. So we've got add, and then we've got, I think we managed to put it in just the right order so that it's not super helpful, I think. Yeah, let's try switching that up. Yep, that'll get us what we want. So this is going to require register allocation in order to work properly. Yeah, let's work with that. This is not the best way to write a test, but I don't feel like trying to figure out how to um, uh, what it should properly be. Okay, so that test should pass now. Why not? There's no slash end at the end. Okay, that passes. So then let's try out this exact same one with the code generation. Or no, the IR rather. See what IR it makes for this. Oh, yeah, I bet you I know what this is. R97. It is this. This fix me. No, I don't need int in here. I need okay, so we need AND, OR, and XOR operations. Oh, and we need opdefs for them too. And we're XOR, all right. No, I'm really not liking this. Yeah, maybe later I can tell Clang format to cut this out and stop doing it that way. I'm not going to do that on camera though. Oh. So then we've got our code generator. It is wanting us to implement these things. So sure, we could try, but it's not going to do it properly. So here's the IR for that. So this is where our current register allocation scheme is going to fall down because we've got V3 here and V3 is used here, but then OR is here. So if we generated the code for this, it would not execute correctly. All right. So we have this code being generated, but we actually do need some sort of proper register allocator in order to compile this code. I think that'll have to wait until next episode, but now at least we've got a motivating example. So I do have something else I would like to talk about in the rest of this episode, but let's just summarize what we've done so far first before we move on. So we've added 3 new tokens to the tokenizer. We have the tokenizer recognizing those tokens and returning them. We also made sure to update the type strings so that works properly and we don't get any errors. And then we've got updates to the parser to recognize those. We've implemented Pratt Parsing, and maybe I can go into what Pratt Parsing is. So we've got precedence numbers for each of the binary operators, and we're passing in a min precedence to the parse binary. We loop here, looking for more operators. If the operator seen is less than or equal to the minimum precedence we've got, then it'll return whatever's in the left variable. And that's either parse primary here, or it can be basically the node that's produced here. Otherwise, if it's greater than or equal to, it'll continue executing and it'll execute this. And essentially what that does is it switches which side of the tree to insert the next node. Generally, we want to go through this loop and produce nodes on the left side of the tree. And I think in my explanation of Pratt parsing before, I said on the right side of the tree, but it's actually the left, because left is easier to generate code for. But if the precedence level changes, then we would produce, we would move the tree that we've produced so far onto the right-hand side and then continue parsing on the left after that. And that's basically what this code does. Yeah, let me know if you want more of like maybe a graphical walkthrough of Pratt parsing, but yeah, I believe that is everything. So yeah, so this has been converted to a Pratt parser now, and we're actually doing that. And then in the EIR, we are generating the code for those. Mainly this is just to get it to compile it all, because it errors right here saying that we've not handled all of the cases. But this code is not going to produce the correct code because it's just using a hard-coded A0, which is not correct. So actually, it'll probably hit this error right here. So yeah, I believe that's everything. In the next episode, we'll handle actually generating the proper code, which will require register allocation. So hopefully that'll be exciting. So there is something that I wanted to talk about. One of the projects I would like to do is a digital circuit emulator, or simulator really. Similar to digital, which I've used on my channel before. The primary difference, the author of digital is not super keen on adding features for the sake of aesthetics, if that makes sense. I mean, maybe I'm wrong. And if you're the author of digital and you're watching this video and you think I'm wrong, feel free to say so in the comments and I'll pin your comment. But yeah, I don't think there's a lot of openness to improving the aesthetics of the program. And there's a few other things. Really, what I should do is either fork it or contribute to digital. That would be the least effort way of going forward. I'm not really a fan of Java, but at the same time, like, I used to write Java at one point. I probably still remember how to do it. I don't know. I'm not really sure. But here's kind of a sneak peek. Now this doesn't do anything. Like, the toolbar is just a piece of text and all it is doing is drawing an AND gate and that's it. But it's a beginning. I'm planning to make it fully native. It'll be written in C. So hopefully those who don't like Java do like C well enough that they might want to contribute to it. I don't know. The other thing is I've been kind of thinking about whether or not I want to try and sell the digital logic simulator. Maybe leave a comment letting me know whether you would pay for such a thing. I'm planning on making it open source anyway. I'm just not going to provide binaries. So there would be an easy way to get around having to pay for the tool. You just compile it yourself. It's just as simple as that. But I put like the compiled versions maybe in the app stores, like the Windows App Store and the Mac App Store. And maybe even if there's an iOS version, I would put it in the iOS and maybe Android. I don't know. The framework I'm using does support all of those platforms, I believe. Not sure about Android, but it does support iOS, I believe. So there's my thoughts. I haven't put a lot of effort into this. I've just done a bit of research and that's about it. Let me know what you think. Let me know whether you would pay for it or not. Because if nobody's going to pay for it, I don't know that I'm going to spend the time to build it. Just being honest there. If I'm not going to make enough to make, ends meet, then I'm going to have to get a job. And if I'm working, there's no way I'm going to have time to build something like a digital logic simulator. I'm just going to be honest with you. So really the only way to make this viable where I would actually have the time to build it is either if people sign them up for Patreon or Ko-fi and do monthly donations, or I charge money for the program itself. and maybe provide keys to people that want to support me on a monthly basis or something. I don't know. I guess keys doesn't make sense. There's ways that I can provide you with a download link for the binaries if you support me on a regular basis. So I don't know. Those are my thoughts. I don't know if I should spend any time on this. I certainly can't make any promises that I'll spend time on this. But I'm really curious to see, what people think. Would it be exciting to have an alternative to digital? If it is, I'd probably want to figure out how to gather some feedback on exactly what to build. I'm thinking one of the biggest features that I know for sure that digital will not implement is a simulation that involves realistic propagation delays. So then you would be able to find the critical path of your circuits. And I think that would be really valuable, whether you're building, discrete logic circuits or building for an FPGA. So yeah, I think something that actually implements propagation delays of some sort would be a really valuable feature. And I think that's been something that's been asked for quite a lot in the community. And there's no program currently that does that except for really old software or proprietary software. So yeah, I guess let me know your thoughts. Should I make it completely open source and just rely on like donations to support it? Or should I put it in app stores and charge money for it? Or yeah, let me know what you think is best. One thing I do know is I want to make sure that at least part of it is open source. I could do the same thing as Chrome does, where the engine is open source, but like the Chrome around it, like the app itself is closed source, and I charge money for it. I don't know. I'm not really sure what to do. So yeah, let me know your thoughts. I'm very curious. Another thing that I have been toying with is starting up a Discord. I'm not sure how to moderate it, so I don't really want it to just be filled with a bunch of spam bots. But if I do decide to post the link, it'll be in a pinned comment down below. So check out the pinned comment for the Discord link. It'll also be in the description of the video. So yeah, thank you very much for watching. Sorry, it's a little bit of a weird episode. Let me know what you think about, doing things between episodes that are kind of more on the mundane side of things. And let me know about Digital Logic, I think is what I'll call it, although that's kind of just a code name for now. I might come up with a different name, but let me know what you think about some sort of digital logic simulator. Yeah. Thank you very much for watching, and thank you for your support, both in watching these videos and whatever else YouTube wants you to do, and also for any donations that you can spare. That's also very much appreciated. So yeah, have yourself a great day. Bye.